These are the solutions to the Junior Cycle Maths Higher Level 2023. Question 1. Zena Carr has a screen which shows the temperatures in degrees Celsius correct to the nearest whole number. When Zena was going to work one day, the temperature on the screen was 18 degrees. Write down 3 possible values that the actual temperature could have been when Zena was going to work. Basically what you have to do here is you just have to make sure that your answers are somewhere between 17.5 and 18.5. So there's an endless amount of possibilities here we can do. So we could go, say, for instance, 17.9, 18.2, 18.35, endless amount of figures you could put in here. Part B will hopefully explain that a little bit more here. So let T represent the actual temperature at a given time. Fill in the missing values in the inequality in T below to show the range of possible values of T when Zena was going to work. So what you have to think of here is that the temperature has been rounded to 18 degrees. So when you're rounding, you always round up from 0.5. So that's going to be 17.5. So when we round up from 17.5, it'll bring me to 18. So T is between 17.5 and 18.5. Now just look at the inequalities here. It says less than, so that's not including the 0.5. So that's everything just below 18.5. Whereas this one is showing the equals to part. So that includes the 17.5. And that'll hopefully make links to the answers we have up here. So basically those 3 boxes that you fill in can be any 3 digits between 17.5 and the 18.5. Scrolling down to part C, if you were to graph the actual temperature T over the course of a day, would it be more appropriate to graph T being a natural number, T being an integer, or T being a real? In this case, we're going to tick the real because real numbers are all numbers, fractions, decimals, and negatives. Naturals are just positive whole numbers. Integers are whole, negative, and positive. But you have to think of it, it's temperatures, and we read temperatures as decimals. It's measurable, basically. So we're going to say, for my reasoning here, real numbers can include decimals, which is a temperature, basically. That should be enough. Or we could say here, it's measurable. And by measurable, if you think of your statistics here, it's continuous. It's something that goes on for forever. It has a fraction or a decimal. Or not goes on forever, but it can have a decimal or a fraction. So moving down now to question 2. A company sells t-shirts on a website. Sometimes when people buy a t-shirt, they return it again to get their money back. The diagram below shows the following information for an 8-month period. SN, the number of t-shirts sold on the website in month N, or N, the number of t-shirts sold in month N that were returned. For N, an element of the natural numbers, where N is less than or equal to 8. All values are rounded to the nearest 50. Okay, so a lot of information there, but hopefully we can kind of just read this from the graph. Use the information in the diagram to answer the following questions. A part 1, how many t-shirts were sold in month 1? So month 1 is sold, we're looking at the red line here. So we're basically just coming up to my graph, reading it off, which is 300. Part 2, how many t-shirts were returned? Returned are the blue ones. So we're going to go again on month 2 this time, up to the blue line, come across where it hits the axis. So that's 50. Part B, which month had the greatest increase in the number of t-shirts sold compared to the previous month? So let's go back up here. So the question is talking about t-shirts sold, and you can see here the big increase in t-shirts here as it jumps. So the question is asking us which month had the greatest increase. I would be saying the 7th month, basically. It would be this period in here. Just be careful how you read that. That's not month 6. That would be the 7th month. Again, if it makes sense, let's go back to the start here. This portion here would be the 1st month. This portion here would be the 2nd month, and the 2nd month would be between 1 and 2. So here this region here would represent the 7th month. So just be careful how you're reading the graph in that case. So our answer here is going to be the 7th month. Complete the table below to show the number of t-shirts that were not returned each month. For example, 350 t-shirts were not returned for month 6. Okay, so let's just go up to our table here. The table shows the amount that were sold and the amount that were returned. So to get the amount which were not returned, we basically just take the two away from each other. So for instance, here in the first month, we take our 300 minus 50. In the second month, same as, we'll take 300 minus 50, and then so on and so on and so on. So we're taking those figures away. So I'm just going to write out the first few of them here. So this one would be 300 take 50, which would leave us with 250. Month 2 has a similar outcome, 300 minus 50, which is 250. And I'll just do the third one here. It's reading off the graph, it's 350 minus 50, so 300. And I'll just fill in the rest of them here. Hopefully you can figure them out by reading it off the table yourself. Okay, so you're just taking away the two figures. Part D, on the given diagram, draw a graph to show the number of t-shirts that were not returned each month. Okay, so I'm going back to the diagram here to fill this in, and we're sketching the not returned, which are these figures here. So going back up to my picture, and I'm going to plot those points. So my first one there is going to be 250, another 250, then I'm plotting a 300 for month 3, then another 300 for 4, 350, 350 for 6, 450 then, which would be here, and finally month 8 is 500, which would be here. Then connect them with a ruler. Mine's just freehand. I don't have a ruler here, but just make sure you would use a ruler to sketch. Okay, so you don't need to fill it in here, but just to explain it, that orange line is representing not returned, in other words. Okay, part E. Which month had the greater percentage increase in the number of t-shirts sold compared to the previous month? Month 3 or month 5, justify your answer. So when we're looking for the percentage increase, try and think of the formula like increase over original or profit over loss, things like that. A nice formula that we use is our difference over original. So we need to get the difference, in other words, the increase, and then put it over the original amount sold. So we're going to do it out twice here, and that'll tell us then if it's month 3 or month 4, or sorry, month 5. So let's do out month 3 for a second. And let's see what's happening here at month 3. So let's go back up to our picture. We're looking for the percentage increase in the number sold. So when we come back up to our picture, we're going to month 3. Okay, they sold 350. In the previous month, they sold 300. So that's basically going to be my difference. So in that month, our sales increased by 50 across that period. So that's going to be my difference. So 50. And I'm putting that over the original. Now the original though won't be month 3. The original is what came first. And that would be our month 2. So I'm putting that over 300. So it's 50 over 300 times 100 over 1. And that's giving me 16 2/3%. Percentage, I should say. Now we're going to look at what's happening for month 5. We do the same thing out here again. We get the difference between the amount sold for that month. Let's just clear our picture here. So we're now on month 5. Sold 450. Previous month sold 400. So that's going to be a difference of 50 over the original, which would be the 4th month, which would be 50 over 400. So 50 over 400 times 100 over 1, and that's getting me 12.5%. So the question wants is which month had the greater percentage increase? Well, the greater increase occurred in month 3 because it went up by 16 2/3 rather than 12.5. That's question 2. Scrolling down now to question 3. The students in transition year mini company make and sell candles. They buy a solid rectangular block of wax measuring 35 by 45 by 16. work out the volume of the block of wax. So volume is given by length, by width, by height for a 3D shape that's in the shape of a box. Then we're just putting in the 3 dimensions. Doesn't matter which one you put in first or last. You're multiplying here, so it won't make a difference. And when you multiply 35 by 45 by 16, I'm getting 25,200 centimeters cubed. Just make sure and put in your centimeters cubed, or marks may be lost. Part B, the students are going to use this wax to make candles in the shape of cylinders. Each candle will have a radius of r centimeters and a height of 9. Work out the volume of each candle in terms of r and pi. So that means that pi and r remain in your answer. It's a cylinder, so from our log tables, the formula for volume of a cylinder is pi r squared h. So v is equal to pi. Radius, we don't know, so we keep that as r. And the only extra bit we can plug in here is our height, which is 9. So rewriting that, I have a volume per candle of 9 pi r squared. Again, the question wants it to leave it in terms of r and pi. So that's as much as we can do. Again though, just make sure and put in your centimeters cubed, just to make sure we don't lose some vital marks. Part C, the students make 100 candles from the block of wax. In making the candles, 10% of the wax in the block is wasted. Use this information to work out the value of r, the radius of the candle. Okay, so first thing we're going to deal with is this 10% of the wax which is wasted. So let's remove that 10% off the original 25,200 that we got in part A. So I'm going to find 10% of 25,200, which is going to be 25,200 multiplied by 0.1, or divide by 100 and multiplied by 10. Or 90, let's just multiply by the 90, because aren't we trying to get to 90%? So multiply by 10 and take it away, or just multiply by the 90. One way or the other, your remainder is going to be 22,680. So that's what we need to use. That's what we're keeping. And that's in centimeters cubed. The question then also says that the students make 100 candles. The question though wants us to get the radius of each candle. So let's kind of narrow this down to how much wax I need for one candle. So per candle, I need to then take my 22,680 and divide that by 100. Now I could have divided by 100 first and then found the 10%. It's the same thing. So that's getting me 226.8 centimeters cubed per candle. So 226.8 centimeters cubed per candle. Now I'm coming back to what I had from the previous part B, the volume of a candle. The volume of a candle is given as 9 pi r squared. We now know that the volume of our candle is 226.8, so I'm subbing that in for V and letting that in equal to my 9 pi r squared. Dividing across now by my 9 pi, divide both sides, that's getting me 226.8 over 9 pi equals r squared. Now you can turn that into decimals now if you wish. I'm going to keep it as a fraction, and then to get r on its own I need to do the square root of both sides to get rid of the square. So that's going to be the square root of, again, you could have had it as a decimal if you wish. I'm keeping it as the fraction, so square root, and that's getting me a radius of 2.8 centimeters. The question wants it to one decimal point, so that's what we have. Moving down now to question 4. Question 4, the ages of children in a creche were recorded. The data are shown in the table below. Represent the data on a histogram. Label the axes clearly. So a histogram is where the bars are touching each other. We need to go up to 19. So let's say we have to go up to 20. So we're going to have to go up in twos here, aren't we? So I'm going to go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and across 0, 1, 2, 3, 4, 5. So down on the x-axis, it's going to represent my ages in years. And on the y-axis, it's the number of children. Now representing the data. So my first one is number of children 6 from 0 to 1. So I'm going up to 6 again with a ruler here. So from 0 to 1. Then I'm going from ages 1 to 2. That's 10 children. Again, it's a histogram, so the bars are going to touch. 2 to 3 is 19 children. 3 to 4 is 3. And finally, 4 to 5 is 5. And that's my histogram. Part B, work out the percentage of children in the creche who are aged 1 to 2. So we're looking for children who are 1 to 2. That's these children here. So that's 10 children. We have a total of 43 children when you add these up together. So 6 plus 10 plus 19 plus 3 plus 5. So that's going to be 10 out of 43 children. So 10 out of 43 multiplied by 100 over 1 to turn it into a percentage, which is 23.26%. Question wants it to the nearest percent, so therefore 23%. So I'm rounding it down to 23. Looking now at part C, use mid-interval values to estimate the mean age of the children in the creche. So this is where I'll just come back up to the table here. So mid-interval values, I need to get halfway between all of the ages. So here, for instance, halfway between 0 and 1 is 0.5. Halfway between 1 and 2, 1.5. Halfway between 2 and 3, 2.5, then 3.5 and 4.5. So they're my mid-interval values. Then I need to multiply the mid-interval value by the number of children in that interval. So I'm going to write that out down here now. So I'm going to have my mid-interval value 0.5 multiplied by 6. Then I add on the 1.5 multiplied by 10 children. Add on my 2.5 multiplied by 19. Plus my 3.5 by 3. And finally, I have a 5 by a 4.5. I divide that then by the total number of children, which we got earlier to be 43. When I work out the top line and add them together, I'm getting 98.5 over 43. Dividing 43 into 98.5 gives me 2.29. The question wants it to one decimal, so that rounds up to 2.3 children. So the mean age is 2.3 years. That's the age of the average child in the creche. Scrolling down now to part D. The table below shows the maximum number of children that one staff member in the creche can mind, depending on the age of the children. So for example, one staff member can mind up to three children aged 0 to 1. So it takes one, you can see here, it takes one person to mind those three children. In the next interval, it says from 1 to 2, for instance. Here, it takes one person to mind those 5 kids. So we basically need to figure out how many people are needed to be employed in our creche, for instance. So if we come back to our table, I'm going to write down actually just beside these here how many children we have in each of these in these intervals. So from the table, I have 6 children between 0 and 1. I have 10 children between 1 and 2. I have 19 between 2 and 3. And then just watch the last one here. It's not 3 to 4 and 4 to 5. It's a total of 3 to 6. So this is adding my final 2, which is the 3 and the 5. So I have 8 here in total. So what does that do to us now? So if we come back up here, it says maximum number of children that one staff member can mind. So one person minds 3 kids, whereas I have 6 kids. So that means I'm going to need 2 staff members to mind those 6 children. In the next interval, I have one person can mind 5, but I have 10. So that's double the amount of people again. So that's 2 people are needed to mind those 10 kids. In the next one person can mind 6 2 to 3-year-olds. I have 19, so if I multiply 6 by 3 or add it, that gets me to 18, Unfortunately, that's not enough. I need an extra person to mind that remaining kid, so I'm going to need 4 people here. So 6 into 19 goes 3 with a remainder, so I have to unfortunately round up for caring for the children. And then finally, I have maximum number of children is 8, and I have 8, so that's just 1 person. So when I add them together, 2 plus 2 plus 4 plus 1 carers is bringing me to 9 members of staff. And that's the end of part D. Now scrolling on down to question 5, it's a little bit of probability and number systems. So the table below shows the outcome when the numbers A and B are multiplied together. A and B are natural numbers. Write odd or even in the box to complete each of the mathematical statements correctly. So even by even must always give me an even number. An odd by an odd will always give you an odd. Again, try some of these out. For instance, 3 by 7 gets me 21. So odd by odd gets me odd. Finally then, odd by even. So again, pick one. An odd multiplied by an even, let's say 4, gets me an even number. This will always be true. So just trial and error a few of them, and you'll show yourself that they're going to be even, odd, and even. Okay, in the next little section, Rory rolls a regular, unbiased, 6-sided die 3 times. He writes down the number on each roll of the die. Complete the sample space or the table showing the different possible combinations of odd numbers and even numbers that Rory could roll. 2 possible outcomes have been filled in for you. Okay, so what could he get next? He could roll an even, followed by an odd and an odd. He could then roll an even, odd, and an even. He could roll an odd, even, even. He could do 3 odds actually. Odd, odd, odd. He could do an odd first, then an even, then an odd. And finally, I don't have an odd, and an even. And that's the 8 possible combinations that he could have. Part C, each outcome in the table is equally likely. Rory multiplies together the 3 numbers that he rolls. Find the probability that Rory will roll an even number as his answer. Well, the first part, to make sure we get our attempt marks here, is that it's a fraction. It's probability, so it has to be out of something, and it's out of 8 because there's 8 possible outcomes from our table. Now, if we come back up here, look at this one, for instance, E. That means even by even by even. Well, we said up above that an even by an even must always be even, and then multiply that by another even. So this one has to be even. So that will always give me an even. Look at the next one. Even by even has to be even. When I multiply an even by an odd, let's come back up to our table here. Look what we get. We get an even. So this one must also be even. Let's look at the third one. Odd by odd will get me odd. Look at it here. But when you multiply an odd by an even, you'll always get an even. So I'm just basically going through the procedures using my table up above. Let's look at the next one. I have an even by odd, which will always give me even. And when I multiply an even by an even, I get even. So you can go through them yourself. I'm only going to do the one that's different, and it's this one here. It's odd by odd by odd, because odd by odd will get you odd, and then when you multiply it by the third odd, it's going to give you a final answer of odd. So part C to this question, find the probability that Rory will get an even number. It's 7 out of the 8 times. The only time he's ever going to get that that odd one is in here, when it's going to be odd, odd, odd. Okay, a lot of odds and evens there. Scrolling down to question 6, which is our sets and algebra. Write down the value, so part A here I'm reading, write down the value of the cardinality of f less g. So the hashtag stands for cardinality, how many basically, and this little symbol here, less or excluding. So what they want us to do is take of f and exclude g. So this is all of f. I want to exclude g from it, so I just need this little region here, because that little region there excludes all of g. So my answer to the first one is going to be x plus 3. Part B, from the Venn diagram, find the greatest possible value of x. Justify your answer. Well, hopefully you can figure this one out here. x has to be 8. It's the greatest value it can be. Think of it here, if I put 8 in for x here, I get 8 plus 3, which is 11, which is allowed. If I put x in here, I go 8 minus 2, I get 6, which is a number. In the final one, I put 8 in, I get 8 minus 8, which is 0, which is a number. But think of it this way. If you put any other number in that's bigger than 8, say 9, I'm going to get a minus 1. I'm going to get a minus answer. And if you come back up to the top here, it tells us in the question that x has to be an element of n, which is natural. So it has to be 1 or bigger. So the biggest number that x can be is actually 8. So if we just kind of justify our answer here, 8 minus x is our value. And I'm going to say that x has to be less than or equal to 8, where x is an element of my natural numbers. So it can be 1, 2, 3, 4, 5, 6, 7, 8, but can't be 9, because if I put 9 in, I'm going to get a negative value here, and I can't have my negative value here. Okay, so hopefully that's short and sweet for question 6. Question 7, then we're getting into coordinate geometry. A, B, C, D are 4 points in the coordinate plane. The points A and B are shown. Plot and label, so don't forget to label it here, the points C and D. So C is 8, 4, so across 8 on the x-axis, up 4 on the y-axis, put a C beside it to label it. D, 3, 6, across to 3, up to 6, put a point, label it D. The next part, write down the coordinates of the point A and B. So A is across 1, up 1, so 1, 1. B is across 6, down minus 1, so 6 minus 1. So you always read x first, followed by y. Part B, Paulina wants to prove ABCD is actually a square. Answer B part 1, B part 2 below to show that ABC is a square. So part 1, show that AB is equal to BC. Those parallel lines are meaning distance. So we need to get the distance, first of all, from A to B. So my point A is 1, 1, B 6 minus 1. Label your 2 points, x1, y1, x2, y2. Then we go to our log tables, take down our distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 to be squared. You sub in your values. For x2, we get 6 minus 1 plus y2 minus 1, all to be squared, which is getting 5 squared plus minus 2 squared. And 5 squared is 25, minus 2 by minus 2 is 4, so that's getting me the square root of 29. So that's a B done. So let's just write that down actually beside it. So that's the distance from A to B. Next one we're going to do is the distance from B to C and show that they are equal. So writing down B, it's 6 minus 1, C 8, 4. Labeling your coordinates, x1, y1, x2, y2. Again, from your log tables, your formula for the distance, x2 minus x1 to be squared plus y2 minus y1 all to be squared in the square root. Filling it in, x2 is 8 subtract 6 to be squared plus y2 minus, now just be careful here, minus from the formula and then minus from the y1, so that's an additional minus in here. So that's going to be the square root of 2 to be squared plus minus minus gives me plus, so that's a 5. So that's going to be 4 plus 25, which is 29. And that's the distance from B to C. And therefore, square root 29 is equal to the square root of 29. So AB is equal to BC. So I'm just stating that they are equal there. Okay, so that's part 1 done. Looking at part 2, without measuring the diagram, show that AB is perpendicular to BC. Now the best way to show lines are perpendicular is to get their slopes. So if you get the slopes of 2 lines perpendicular, what you'll notice is that in order to show they're perpendicular, one slope is flipped with a different sign. Now to prove that though, you multiply the 2 slopes by each other and you'll get -1. So that's how we prove if two slopes are perpendicular. So first thing we need to do is get the slope of AB. So let's write down AB again. A is 1, 1. B is 6 minus 1. Label them. x1, y1, x2, y2. Go to your log tables. Take down the formula for slope. y2 minus y1 over x2 minus x1. Filling that in, -1 over x2 minus 1, which is -2 over 5. So that's my first slope found. Then, so that's the slope of, I'll just put in brackets here, AB. And then looking for the slope of BC this time. So labeling my 2 points B and C. 6 minus 1 and 8, 4. x1, y1, x2, y2. Log tables, take down your formula. M is equal to y2 minus y1 over x2 minus x1. Filling it in, we get y2, 4. Subtract y1, so a double negative there again. x2, 8 minus 6. 5 over 2. So that's my slope of, let's call BC. Okay, so you can see that they're flipped with a different sign, but you need to prove it. The question wants us show that they're perpendicular. So let me just write the rule here again. So to show perpendicular, you multiply your two slopes and you'll always get -1. So if I multiply my first slope times by my second slope, I get -1 is equal to -1. So therefore perpendicular. Okay, so once you get them equal to -1, then we're happy that they're perpendicular. Looking at part C now, Kieran makes the following statement. Kieran's statement: every parallelogram is a square. Is Kieran's statement true or false? Justify your answer. I'm going to say here that every parallelogram is surely not a square, because the rule is that a square has to have a 90 degree in it, and parallelograms do not necessarily have 90 degrees in it. So this is a parallelogram here, that this could be, say, 110 degrees, and this could be 70 degrees. So they don't have 90 degrees necessarily in it. So I'm just going to say not all parallelograms have right angles, because we know a square does have a right angle. So all parallelograms do not necessarily have right angles. Write down the converse to Kieran's statement, or the opposite to this. So Kieran has said that every parallelogram is a square. I'm going to say every square is a parallelogram. And this is true, because if you think about the definition of a square is that opposite sides are equal, opposite angles are equal, or 90 in other words. And then if we look at the rule of a parallelogram may look like this, but the rule says that opposite sides are equal, which is the same as my square, and opposite angles are equal. And those opposite angles could be 90 degrees. So every square is a parallelogram. So it works the opposite way around. Okay, that is that question finished. Having a look now at question 8. Convert 7.5 kilometers to meters. Kilometers has 1,000 meters, so I'm going 7.5 multiplied by 1,000, and that's getting me 7,500 meters. Part B, a plane P took off from an airport. It left the ground at the point T. After a few minutes, it was 7.5 kilometers from T, and it was 200 meters directly above level ground as shown in the diagram. Use trigonometry to work out the size of the angle marked E. Okay, first thing I would do here is see how this one is in meters, this one is in kilometers. Let's change this to 7,500 as per part A. Then label the diagram as a right angle triangle. So we're going to use our sine, cos and tan. Opposite the angle is opposite. Across from the 90 is my hypotenuse, and the third remaining side is adjacent. Then write down your 3 rules. Silly old Harry caught a herring trawling off America. Sine, cos and tan. Which one are we going to use? We're going to use the rule that uses hypotenuse and opposite. Hypotenuse and opposite. So we're going to use sine in this case. They're the two sides that we need. So we're going to use sine of angle, which is our E, sine E, opposite, which is 200, over our 7.5, which is 7500. We need to get E on its own. So we need to do the inverse of this. Sorry here, things are just popping up, but I'm going to move over the sine here. So that's going to become E, my angle, sine inverse on your calculator of 200 over 7,500. So just be careful on your calculator here to press the inverse button. So your angle E is 1.528 degrees. The question wants it to 1 decimal, so therefore E is 1.5 degrees because I'd round the 0.528 down to 0.5. Okay, part C, part 1, write 20 minutes as a fraction of an hour. So there's a little box here for rough work here. So we've 60 minutes in an hour, so it's 20 over 60. Divide by 10 gives you 2 over 6. Divide by 2 gives you 1 over 3. So it's 1/3 of an hour, 20, 40, 60. During part of its flight, plane P traveled 598 kilometers in 2 hours and 20 minutes. Work out the average speed of the plane. Okay, so this would be, as soon as you see the word speed in here, you should be thinking distance, speed, and time triangle. We're looking for speed. So we cover the speed and we're left with distance over time. So speed is equal to the distance traveled, 598, over the time. Now the time took 2 hours, 20 minutes. Now you can turn that into complete minutes if you want. So 60 plus 60 plus 20, so 140 minutes. Or you can use kind of what we found in part I here as a fraction. So 20 minutes as a fraction is a third. So 2 hours and 20 minutes is 2 hours and 1/3. So 2 1/3 hours. So it's up to you how you want to type it in your calculator. So speed is equal to 598 divided by 2.33333, or 2 1/3, which is giving me 256.2857 kilometers per hour. Question wants it to 1 decimal, so 256.3 kilometers per hour. The 0.28 will round up to 0.3. Okay, this question continues on the next page, so we're not done yet. Part D, in the diagram below, each of the points A, B, C represent an airport. The plane travels 598 from airport A to B and then travels on to C. Work out the distance from A to C. So this is the length of the line we need here. Bit of work involved in this one. Let's focus in on this triangle first. So I'm going to split this question into 2 triangles. This one and then this one. And what I'm going to do here is, on the green one, I'm going to get this length here using Pythagoras theorem, because we'll have 2 sides and we're missing 1 side. And then I'll come over to the other one in a second. So using Pythagoras theorem, our formula c squared equals a squared plus b squared. The c is always the hypotenuse, so that must be the 598. So 598 squared, crossing the 90, equals the other 2 sides. Now it doesn't matter which is a and which is b, so 280 squared plus my x squared. Getting very large numbers here, so squaring this out, I get 357,604 equals 78400 plus x squared. Moving to 78,400, I get 357,604 minus 78400 equals x squared. And that's leaving 279,204 equals x squared. Then to get x on its own, I need the square root of that. So 279, as I said, they're very large numbers here. So this is getting me a value of about 528.4 kilometers. So that's the distance from A to this little point here. Next thing I'm going to do now is, let's just clear off my picture. I'm going to get the distance. Well, actually, let's write that in. I have this length here, which is now, let me just put it in a thicker color. This one here, I've got to be 528.4. Next thing I'm going to do is I'm going to look at this triangle. Now, I have an angle and a length this time. So this is going to be my sine, cos, or tan. Labeling my picture here again. So across from the 90 is my hypotenuse across from the angle is my opposite, and the remaining side then will be my adjacent, which is the side that I actually need here. So I need to use adjacent, opposite, and the rule that uses, or the ratio that uses adjacent and opposite, is going to be tan. So tan angle is equal to opposite and adjacent. Filling that in, it's tan 35 is equal to opposite, which is 280, over my adjacent. Let's give that a name here now. Let's call that y, for instance. So I'm going to put that over y. I'm going to then cross multiply. So tan 35 multiplied by y stays as tan 35. Turn that into a decimal if you want. I'm just going to stick them together because it means multiply. And 1 by 280 is 280. To get y on its own then, I divide both sides by my tan 35, or whatever that is as a decimal if you're working in decimals. And that gives me an answer of 399.88 kilometers. So let's put that back up in my picture here. That would be 399.88. Okay, a lot of work there. Now to get the final answer, the length of this line AC, I need to add those two answers together. So I'm just running out of space here, so I'm just going to keep it over here. So therefore my answer is going to be 528.4 plus 399.88, which is giving me a final answer here of 928.28 kilometers. Question wants it, I think, to the nearest kilometer. So that's going to be 928 kilometers. Question 9, multiply out and simplify. So draw your arrows into the brackets first of all. 4x by 5x gets 20x squared. 4x by 4, 16x. Minus 3 by x, minus 3x. Minus 3 by minus 2 gives me minus by minus gets me plus. Grouping like terms, 16x minus 3x is 13x. So 20x squared minus 13x plus 6. Factorize fully 9 minus 25y squared. This is our difference of two squares. So 9 can become 3 squared and 25 becomes 5y all to be squared. Difference of two squares then is two brackets, 1 minus 1 plus. So 3 minus 5y, 3 plus 5y. Part C, write the following in the form 5 is to the power, where P is an element of Q. So Q are your fractions and decimals, basically your integers. Your reals, I should say. So so it could be fractions, decimal numbers here. Where are we going to start with this? We're going to have to change that 25 first of all, aren't we? So that'll be 5 to the power of 7 multiplied by the 25 can become 5 squared. So let's just change that first, which is the same as 25 to the power of 3. So 5 squared to the power of 3 all over a square root is the same as to a power of a half. So these are coming from my log table, some of my rules here. So actually I'll just change that in color here. So anything I've changed is in red. Keeping the top here, 5 to the power of 7 multiplied by the rules in logs tells me when I have 5 to the power of something squared inside and then to another power, I add those powers. So that gets me 5 to the power of 5 when I add the 2 and the 3 all over 5 to the power of a half. Sorry, my fault. The top one there should be 5 to the power of 6. 2 by 3, I should say, gets me 6. I multiply them. Then on the top line, I'm looking now at my powers, 5 to the power of 7 multiplied by 5 to the power of 6. Multiplying the powers, I add them. So that's getting me 7 plus 6, which will get me 13 over 5 to the power of a half. So 5 to the power of 13 over 5 to the power of a half. And when we divide powers, we subtract them. So that's 5 to the power of 13 minus the half, which is 5 to the power of 12 and a half. And that's my answer, 5 to the power of 12 and a half. So a little bit of work and changing things around there. Question 10 now. is a financial maths one. Michelle must pay universal social charge, USC, on her gross income. The income bands and rates are as follows. Part A. Find the amount of USC that she must pay at each of the first two levels, the 1.5% and the 3.5%. Okay, so first one here is going to be the €12,012 at 1.5%. Now, different ways of getting percentages here: divide by 100 and multiply by 1.5, or we could just go to our calculator and go 12,012 multiplied by 0.015. So divide the 1.5 by 100 to get 0.015. And when I multiply that out on my calculator, you're getting €180.18. Next one then is the next €5,564 at 3.5%. Again, divide by 100, multiply by 3.5, or go 5,564 multiplied by 0.035 when I divide by 100, and that's 194.74. Again, just fill them into the spaces they have provided for us, so 194.74 and 180.18. Okay, Michelle's gross income is X, so she's some pot of money valued at X euro. Michelle pays a total of 5% of her gross income in USC. So in other words, when she takes her USC out of her total pay, it accounts for a total of 5%. Write an expression in terms of X for the total amount of money that Michelle pays in USC. Okay, so think of it like this. Michelle has some pot of money, X euro. We then want to take away, or let's remove the first two bands here, these two here. We know that these two can come out of that. So if we take out those two first of all, so let's say we take out the €12,012 and the 5,564. So let's get rid of those first of all. So that means it's going to be her amount of wages, or whatever amount of money she has, minus, adding these together gets €17,576. So that's how much money she has left, and she has to pay that then at her new USC band, which is above the 17,756. There's that figure here. So that's going to be at the 7%. So at 7%. But don't forget that amount of USC that she pays at 7%, we still have to account for these two USC rates. So here now, I'm going to add them on. So I'm going to go plus the 180.18 and the 194.74, the 1.5 and the 3.5 USC rates. Now I'm going to use my little knowledge of here. Look how we found a percentage here. We times it by the decimal. So here I'm going to go whatever amount of money that is, X minus the 17,576, multiply that by 0.07, and then I need to add on my other two rates, which is €374.92. And I would say that's enough. Write an expression in X. So there's our expression. So a little bit of work in getting to that. The next part now, find the value of X. So in part C here, it wants us to solve this expression now that we have for X. Now think of it again in a different way here. We have our USC, which is the same as 5% of the total. So 5% of some amount of money. Now we have Michelle's USC written as something a little complicated. We have it written as X minus 17,576 times 0.07 plus the 374.92. But that's equal to 5% of X, some amount of money. If we multiply in this 0.07, we get 0.07x minus 17,576 by 0.07 is 1230.32. Then we add on this amount, the 1.5 and the 3.5% of USC, and that's equal to 5% of x. Now 5% of x is the same as going x multiplied by 0.05, same way we've done this whole question. So tidying this up now, we have 0.07x. We could multiply this and bring it over, so that's going to be minus, let's just make a bit of room here, so 0.07x minus 0.05x, and then move the numbers to the right hand side. So that'll be a 1230.32, and then the 374.92 becomes a negative. If we subtract these together, that leaves us with 0.2x equals, and 1230 minus the 374 is getting 855.40. Then divide across both sides by 0.2, and that'll get us a value of x of 42,770 euro. And that's how much x is, Michelle's gross income. And that's the end of question 10. Scrolling down now and having a look at question 11. 30,000 people went to a football match in Star Stadium. After the match, the 30,000 people left the stadium at a constant rate. The graph below shows P, the number of people still in the stadium, T minutes after the end of the match. 2 points are marked on the graph, G and W. Part A. The point G has the coordinates 6, 21,000. Explain what the 6 and the 21,000 mean in the terms of the number of people in the stadium. So let's first of all focus in on the 6. What does this mean? The 6 stands for minutes, and the 21,000 is standing for people. Okay, so the graph is given down the bottom here in minutes, and on the side here people. So let's put that into a bit of text for a second. So what's happening here? So after 6 minutes, since the end of the game, so the game has finished, it's 6 minutes later, so after 6 minutes since end of the game, 21,000 people still remain in the stadium. Star Stadium, I think they called it, was it? Okay, so that's what the point G stands for. 6 minutes left after the match, 21,000 people are still in the stadium. Part B, it took 20 minutes for all the 30,000 people to leave the stadium. Use this fact to write down the coordinates of the point W. Okay, so we've come out some amount. That's the amount of people. So we've come out 30,000. We haven't gone up or down anything, so we've no one left, basically. Sorry, we've come out time, I should say. We've come out 20 minutes. This is our 20. So we've come out 20 on the X, which is time. We're not going up or down because all our people have now left. So 20 minutes, 0 representing the people. So 20, 0. See part 1. How many people were in the stadium 12 minutes after the match had finished? So the equation of the graph here. So we can use this here to solve for P, the amount of people. So we're going to go P is equal to 30,000, 30,000 being the original amount, 1500 multiplied by T, T is 12 minutes. So that's getting me P is equal to 30,000 minus 18,000. So after 12 minutes, there are 12,000 people left. Explain what the 1,500 in this equation means in terms of the number of people in the stadium. Well, the 1,500 basically represents the amount of people who leave the stadium per minute. That's what that's standing for. So 1,500 leave the stadium per minute. We should probably say after the match, not during the match. So per minute after the game. Okay, so that's what the 1,500 is representing here. Question 12. The diagram below shows a curve, ABC. There's a bit of information there you can read yourself. Part A, use only a compass and a straight edge. Construct one of the axis of symmetry of the curve. Now, I don't have the equipment here on the screen to do that out. So what you would be using here would be your construction called the perpendicular bisector. of two sides basically. So it looks something like this. You get your perpendicular bisector, say of AB. So it looks something like this, and then get the other side, looks something like this, and then you draw your line then that goes down. It's basically cutting the shape in half. But again, I leave that up to you using the perpendicular bisector construction. B part 1, write down the size of the angle ABC. So if we come back up to our picture here, ABC, the question tells us, so we have three angles here. It tells us that it is a equilateral triangle, does it? Does it tell us anything about the type of triangle? It does here. It's an equilateral triangle. Equilateral triangle meaning all sides are the same and all angles are the same. So that's going to be three angles. All angles add up to 180 degrees. So 180 divided by 3 is 60 degrees. The length of the straight line segment BC is 40 centimeters. Find the length of the circular arc from B to C. So let me just come up to our picture here and we'll figure out what this is asking us to do. So it's telling us the length of the straight line from B to C is 40 here. The question wants us then to find the length from B to C, this length here. Now, kind of hard to picture this, but you're going to have to visualize this shape here as if the triangle, let me draw these here for a second. The triangle ABC fits into a circle. So imagine I have another one up here. So it kind of looks like this. And then there's a circle that kind of goes around these, touches the corners, comes down and then goes through B and over to C. So it's like this orange line here, the curve. That's my full circle, very rough, but looks something like this. And what you have to picture now is we're just focusing in on this sector of the circle here. That's what we need to focus in on. And it's an equilateral triangle. So this is 40, which means that this is 40 and this is 40 because all sides are equal. And that 40 is now representing the radius of my circle. So that's going to be 40 here, the length of the radius of that sector. And then from that, I'm going to use that to get that length of the curve. So that's what you kind of have to visualize here in this question. So if I scroll back down here, so my sector looks something like this. I have a 60 degrees and a 40 and a 40, and I'm trying to get the curve. From your log tables, the length of the curve is angle over 360 multiplied by 2 pi r. The angle in this case is my 60 degrees because it's equilateral multiplied by 2 pi, radius being my 40. Sorry, I shouldn't have a square there. Don't know why I put the square in. So 2 40s are 80, and then multiply all that by pi and 1/6, which is giving a length of 41.8879 centimeters. Question wants it in two decimals, so 41.89 centimeters. So the tricky bit to that is kind of visualizing it, but I think it's no harm to kind of draw out the full circle that goes around the shape. Looking now at question 13. Companies making a large rectangular poster as shown in the diagram on the right. The top section will be a square. So the square is this bit here that I've marked in red. The bottom section of the rectangle has a height of 0.5, this part here. The width of the poster is X. So again, if this is X down the bottom, that means since it's a square, all of these have to be X. The question wants us then in part A to write down the total height of the poster. So the height of the poster is going to be this side here, which is X, and then the side here, which is 0.5 meters. So it's going to be X plus 0.5. Part B, the total area of the poster is 50 meters squared. Show that that can be written as 2x squared plus x minus 100. So area is length by width. They haven't given us a lot of room here maybe. So area is equal to length by width. So that's x by the height, which is x plus 0.5. Multiply them in, I get area, which is x squared plus 0.5x. Now to tell us the area here, it's 50, so sub in my 50. And to get rid of the decimal, the 0.5, I'm going to multiply across by 2. So 50 by 2 is 100 equals x squared by 2, 2x squared, a half x by 2, 1x. Then I move everything to one side, so that's leaving me with 2x squared plus 1x minus 100 equals to 0, and then just put the 0 at the back. I don't need the 1 in front of the x, so that's 2x squared plus 1x minus 100 equals 0. Solve the equation now to find the value of x, the width of the poster. Give your answer in meters, correct to the nearest centimeter. So we're solving a quadratic equation here, and it wants it to nearest decimal. So your hint there would be to use the quadratic formula from your log tables. So that's your formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. Your a is the number in front of the x squared, which is 2. Your b, the number in front of the x, which is 1. And your c is the constant, which is minus 100. Filling that in now, x is equal to minus b. So minus 1 plus or minus the square root of b squared, which is 1 squared, minus 4 times a times c, which is minus 100, all over your 2a, which is 2 2's. So x is equal to minus 1 plus or minus the square root of 1 plus 800 over 4. So x is equal to minus 1 plus or minus 801 over 4. Okay, you type that into your calculator, so you're going to do both of them here. So you're going to have x is equal to minus 1 plus root 801 over 4, and x is equal to minus 1 minus root 801 over 4. And I'm just going to go straight to answers here if you don't mind. So x is equal to 6.83 and x is equal to minus 7.325. Now be careful here, we don't need this one, there's only one solution. Our solution for x is going to be 6.83 meters, because we can't have a negative length. So this is a practical problem solver here for the length of a picture, so we don't accept the negative answer. So 6.83 meters or 6 meters 83 centimeters, whichever way you want to write it here. It said correct to the nearest centimeter. Yeah, so that's about right. Question 14. The diagram below shows a triangle ABC not to scale. The points D and E lie on a C and BC respectively. And then it's telling us that these two angles are equal to 90 degrees. The length of some of the sides are given in the diagram. Work out the value of x. Okay, so to work out the value of x here, I'm going to use this triangle here, CDE. You can see here that I'm given two sides, and I need to find the third side. It's a right angle triangle, so I could use my Pythagoras theorem here to find that missing side. So c squared equals a squared plus b squared. Just make sure that your c is always the side across from the 90, so that's your 15 squared. And the other two sides are your a and b, and it doesn't matter which goes in as a and which goes in as b. 15 squared is 225 equals 9 9s or 81. X by x is x squared. Subtracting 81 from both sides leaves you with 225 minus 81 equals x squared. So x squared is equal to 144. And to get x on its own, you get the square root of 144 to get rid of the square. So x is equal to 12. Is it in centimeters or anything? It's not. So we could just say 12 units. Okay, so that's x found. It's 12. The next part, using similar triangles, work out the value of y. Okay, so what we need to do here is similar triangles means you're going to have two triangles here. So the first triangle I'm going to use here is this one. I'm just going to label these different colors. So D, E, and C. So that's my first triangle that I'm going to draw out here, the smaller triangle that I'm using. So let me just sketch that here. So I have D, E, C. I'm just going to color code these because sometimes it can make life a bit easier. So that's what we have. And filling in my dimensions, I have 15, x, which is 12, and 9. The next triangle now that I'm going to look at is the larger triangle, this one here, ABC, this full triangle. Now look where the right angle is on this one. So I'm going to basically just flip the triangle around first of all, so it looks something like this. Let me draw it first. I just want to keep it in the same shape as the triangle DEC. So the A is down here now, the 90 degree. So that's going to be my red dot. So that's my 90 degrees. So that's going to be my A. My C, we originally had it color coded as blue. So that has to still be my blue dot. So that's going to be here, which is going to be my C. And my remaining dot has to be a green one, which is the other end of this line here, which is the B. So that's how your shape should look. And now we fill in our dimensions to that. We have A to B, which is Y. We have B to C, which is X plus X. It's two X's actually, which is what? We had them as 12, so 2 plus 12. So this length is actually 24. And A to C, do we know anything about A to C? We don't actually, we only have part of it. So I'm going to leave it out for now. We might need it. Let's see. So what do we know here? So we have a green dot to a red dot, which is 9. We have a green dot to a red dot, which is Y. So they're pairing up to each other. Those sides are going to be similar. So we can match them up as a fraction. Doesn't matter if you put the bigger one over the smaller one, just be consistent. So I'm going to start with the smaller triangle on top, larger triangle on the bottom, 9 over Y. Then I'm going to match up at the other two sides that I'm given. So look here, I'm given a 15, which is a green dot to a blue dot. So I'm going to write my 15. Go to the other triangle and match up the green dot to the blue dot, which is the 24. So I'm putting that 15 over 24. I can do this when triangles are similar. Similar triangles means the angles are all the same, but they've told us they're similar. I need to solve this fraction, so I cross multiply. I'm just running out of space here, so I'm going to do it over here. When I cross multiply, I have 15 times y, which is 15y. I have 24 by 9, which is 216. I divide both sides by 15. So that's leaving me with y is equal to 216 divided by 15, which is 14.4. Question wants, it doesn't say actually to one decimal or not, so I'm just going to leave it as 14.4 units. It doesn't say if it's in centimeters or not. That's the end of question 14, and that's the end of the exam paper.